I'm Mr. Auerbach. I will be your video science teacher today. Before we start, I'd like to say, hello Rebecca. You're probably the only person that's ever going to watch this, and I'm hoping you will watch this. Here we go. Okay. So what we're doing today is we're going to work with our units of energy, and we're going to learn to convert between them. So if you have a certain amount of heat energy, how much mechanical energy is that equal to? Heat and chemical. Any of these you can do a conversion between. We talked about yesterday, we don't really have a unit that we're going to use for radiant energy. We're just going to go with its other equivalents. And so, if I wanted to know, by the way, if you're going to look at these things, the units of mechanical energy are, I think, on page 99. You all can get books, by the way, if you want to, as you did yesterday. That was a picture. You can use your book on page 99 to get the conversion factors for doing these problems. Page 99. And that has all of the units that we went over yesterday that go with all of these, and it has the conversion factors that we talked about, of how many of one is equal to another, etc., etc. And so, let's do a problem. If I asked you, here's our problem box here. How many calories in 1 ton of TNT, or 1 TNT? Remember, the abbreviation TNT stands for ton of TNT, even though the abbreviation TNT actually stands for trinitrotoluene.
How do you know which one they're talking about?
What do you mean?
Like if they say, like, 3 tons of TNT, are they saying 3 tons of 1 ton of TNT, or are they saying 3 TNT?
Same thing. I mean, 3 TNT is 3 tons of TNT, so I mean it's the heat released or the energy released by 3 tons of TNT.
Yeah, but
so,
you said that 1 TNT
yeah.
is 1 ton of TNT.
Right. Well, I think it depends on the context. Like if we were in a chemistry class and we wrote 1 TNT, that would probably mean 1 molecule or 1 mole of trinitrotoluene. But I mean, I think that in the case of this class, I'm going to be pretty clear, what it is. So we're back. So, all right, what do we have to do? Let's look at the conversion units that we have. I like to just use the ones that are given. It's easy enough to go online and to get a direct conversion, but it's also good to work with what you have, because with a little mathematical trickery, you can make any of these work. So let's see what we have. Oh, let's change this. Let's make this 7 tons of TNT, because otherwise it's not going to be a challenge. Because we have a direct, there, and that's easy to change in your notes, and for you playing along with our game at home. So 7 tons of TNT, because we have a conversion. This one's really easy. We have the conversion that, purple marker. Here it is. Purple marker is perfect for television. 1 ton of TNT. Oh. I heard that. Right here on page 99, it says 1.04 times 10 to the 9 calories. So what does that mean? What does that mean? A little review of scientific notation for those of you playing along with our game at home, and for those of you here who might not remember how the heck this works. So what this means is 1.04 times 10 to the 9th power. And what that's really telling you is that this is an easier way to write this than this. This is the actual number. Let's do this. How do we do this? Does anybody remember how you do this? Yep. 1.04.
You'd move the decimal 9 places to the right.
Right. Whatever this number is, for the simple, quick and dirty, how do I solve this without really having to worry too much about it? You just move the decimal point as many places to the right if this is a positive number. And if this was 10 to the negative ninth, what that would be telling you is that it's a tiny, tiny, tiny number and you move it to the left. But it's not. It's a lot of calories when you blow a ton of TNT. And so we're going to move it to the right 9 places. And then we're just going to put zeros in until we get to the decimal point again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our decimal. And then we'll just put in zeros here. And we'll erase these because it makes it irritating to look at. It's not as pretty and neat as I am accustomed to. Okay, so what does that give us? And then putting in the commas, that gives us 1,040,000,000 calories. Is what that means. Equals 1 TNT. And so how are we going to get our answer? It's pretty easy. Like if you think of it this way, okay, I have 1 ton of TNT. If 1 ton has that amount of energy, 1.04 times 10 to the 9, I have 7 of them. So all you have 7 of something that 1 ton is this much. So what you would do is you would get your calculator, and now I have to get my calculator. All right, and I'll just put it in this way because this doesn't do scientific notation. 1, 0, 4, 0, 0, 0, 0, 0, 0. 0. One more 0, right? We good? And then times 7. And that gives us 7, 2, 8, 1, 2, 3, 4, 5, 0, 0, 0, 0, 0. Bam, bam. And so let's put that into scientific notation just for the heck of it. The idea of for those of you who are not familiar with this again, the idea of scientific notation is to express a number that's between 1 and 9. In other words, so that it's easy, and then you multiply it times the number of powers of 10 you have to put it to. So we would start with. Are you telling me? Is that the answer you got? What's that?
You're wrong. It's 7,280,000,000.
You missed the 0 on the calculator.
I did? Thank you.
2 zeros.
2 zeros?
Yeah.
Okay. My crack team of mathematical backups here has informed me that it is 7,280,000,000, and that seems correct since this is 1 billion and we're multiplying it times 7. That seems pretty clear. Okay. Thank you, crack team of mathematical editors. And so turning this into scientific notation, 7.28 is what you want your base to be. And then how many times would you have to move the decimal to get it there is basically times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. 7.28 times 10 to the 9th. And what have we forgotten?
Calories.
Calories, right. Always write your unit, folks. Always write the unit. If you write the unit, then you'll know what you're talking about. If you don't, you can get lost in the middle of a problem. So always write your unit. Okay, even though I didn't write it there. All right, so this is what it is. It's not that hard to do these. You really just have to know whether you're multiplying or dividing. Okay, so if you need to write this down, you can pause. Otherwise, I'm moving on to the next problem. Unless you guys need a minute to write this all down. You're good? Okay. let's see. How about let's see if we can do. Let's see what's one that's maybe a couple steps. How about well. How about foot-pounds and calories? We'll do that. So let's say I want to exert 400 foot-pounds. So we're going to go from mechanical to foot-pounds to calories. Why not? We'll stay with calories for a second. So let's say, give me a number. How many foot-pounds? You guys decide.
57.
57 foot-pounds equals how many calories? How about that? So if I want to take 1 pound of mass, weight, and I want to move it over 57 feet, or if I want to take 57 pounds and move it 1 foot, however you want to think of this, how many calories of energy is that equivalent to? So, okay, in this case, we're going to look again, and we're going to see, luckily, that a foot-pound actually can be converted directly to calories again. So this is one where we don't have to worry about it. And so, our conversion here, I'll do it right here. 1 foot-pound equals 0.329?
Yep. 3239.
3239. We'll just call it 324 calories. Okay. So again, folks, this is mathematical thinking, applied mathematical thinking. Sometimes you just have to not worry about it because the answer's right there. You just get numbers in your head, and sometimes people get all confused, and I'm one of them half the time, so don't worry. But I'm here to help you not think that way, because look, if 1 foot-pound is this many calories, what are we talking about? We're talking about how many foot-pounds we have. So again, 0.32. Think of it this way. There's 1 foot-pound. So there's one. How do you think about this? So do you have to multiply or divide? Well, there's 1 foot-pound, and so I've got 57 of those, right? That's the way to think about this sort of math. Is if you have to visualize it, I'm not going to draw 57 little circles, but picture me having just drawn 57 little circles here, and each of those is this many calories. And so then it becomes clearer what you have to do, and that is to multiply your 0.329 calories per foot-pound times 57 foot-pounds. And if you think about it, if you really want to think about it, this is some mathematical trickery. But sometimes people really aren't clear on how we get from one unit to another. And if you think about this, okay, 0.329 calories per foot-pound is really calories over foot-pounds, because per really means divided by. You're eating food in my class. Luckily for you, the camera is on. It will not catch this. It would catch the savage beating that I would put on you. But anyway. Okay, so calories per foot-pound. And another little bit of math trivia is that if you have, let's draw this out as a fraction. This isn't for everybody, but some people, like people that took chemistry, generally will have at least experienced this. That turns into a mathematical statement, 0.329 times 50, oops, wait, no, it doesn't. 0.329 calories times 57 foot-pounds over foot-pounds. Anything over itself, anything divided by itself, everything divided by itself, even if it's a word, that's the weird thing, even if it's a unit of measurement, foot pounds, inches, blah, blah, anything, any number over itself equals 1, right? Anything divided by itself, 6 divided by 6 equals 1, ton divided by ton equals 1, Auerbach divided by Auerbach equals 1. It's all a matter of the same thing over itself equals 1. And if it's 1, you can get rid of it because everything times 1 is just itself. And so it's a little mathematical trick, but that way you can cross out foot-pounds and then automatically your unit ends up being correct. You end up with the right unit. And so 329 times 57 equals 18.753. We'll call it 18.7 since really our largest amount, I actually should call it just 19, but we'll call it 18.7. I'm breaking some other math rules there, but no, 18.8. 753 would round up to 18.8. 18.8 what? Calories. Never forget your unit. Okay. So that's how much energy it takes to motivate one 57-pound weight, 1 foot. So you burn 18.8 calories doing that. Yes, indeed. Okay. Okay, you guys make one up. I bet you can make any one up and I can solve it.
Let's get our Bach brain buster.
Of just
Yeah.
of just foot pounds. All right.
It was for a while.
What about 17 BBLs times 53 foot-pounds?
17 BBLs into foot-pounds. So you want me to convert barrels of oil into foot-pounds.
Yeah.
And then you guys have electricity in the wings. I hear that's what you're doing. All right, so we'll do hold on.
Alright.
17 BBL Can we see that?
Yeah.
Does that show up on the screen, little screen at all? Can you see it?
Yeah.
You can read it? Okay. 17 barrels of oil equals how many foot-pounds? So let's see what I've got here. It looks like I do not have a direct conversion. So, okay, good for you, good for you. So what I have here, I've got a few different possibilities. I think I see the one I'm going to go with. So they tell me that 1 BBL, uh-oh. Okay, so we're going from barrels of oil to foot-pounds. All right. And my conversion factors that I'm going to use, I'm going to need multiple ones here, is that 1 foot-pound equals a certain number of BTU. 5.8 times 10 to the 6th. Oops, not 16 to the 6th. 10 to the 6th BTU. And then, so because that's the best I can do, that's all I'm given for BBL is BTU. So now I have to hope and pray that there's a conversion from BTU to foot-pounds. Yes! And then I have 1 BTU equals probably a whole bunch of foot-pounds. 772 foot-pounds. Okay. So that's good. And you notice how a BTU is a heck of a lot more foot-pounds. A foot-pound is only 0.3 calories. But it's even a lot less BTUs. It takes 772 of these to make 1 BTU. Anyway, let's do the problem. So, all right, I've got 17 BBL Let's see, so am I gonna multiply or divide? Uh-oh. What did hold on, what did I? Oh, I made a mistake. I wrote foot-pounds up here, but I should have written BBL. My bad. 1 BBL. 1 barrel of oil is this many BTUs. I'll edit this out so it looks like I didn't screw that up. 1 barrel of oil is a certain number of BTUs. So 17, again, if 1 barrel of oil is this many BTUs, 5.8 times 10 to the 6th, that's 1 barrel of oil, and I have 17. So again, it's a matter of just saying, okay, how many of these I multiply? That tells us I need to multiply times 17, because this is how much 1 is, and I have more than that. Okay? All right, so let's do that. Okay, Mr. Auerbach, let's do that. 17 barrels of oil times 5.8 times 10 to the 6th BTU. For those of us playing our game at home, let's turn this into an actual number so that we can put this into our little calculator, since I didn't make you all buy scientifical calculators, scientifical calculators. 17 times, what would this be? So that's 5.8, move the zeros over, the decimal over, 1, 2, 3, 4, 5, 6, 5, 8, 0, 0, 0, 0.
Times that.
Did I do that right?
I'm 17.
That's 5,800,000 BTUs. So,
Oh, that's what is it? So,
17 times 5, 8, 0, 0, 0, 0, 0. C'est igual. Equals 986,000,000. That's 98,600,000 BTUs. So 17 barrels of oil, that stands to reason. 17 barrels of oil, you burn them all, whether you burn them hobo style or whether you just blow them right up. That's a lot of BTUs if you think about it. I mean, you could heat a lot of houses with that much energy, so it stands to reason that's a big amount. So don't be afraid if you get big numbers with this sort of stuff. So okay, so we did this part. We went from barrels of oil to BTU, and now we have to do this part where we go from BTU to foot-pounds. And so, if it's okay, I'm going to erase this and I'm going to put this number up here. So that means we have to do 98,600,000 BTU equals how many foot-pounds? Okay, now I've written that, I can erase this. So, okay, and now we have, wow, 1 BTU equals 772 foot-pounds. So again, 772 foot-pounds. So already with 1 BTU, we can move one pound of mass 772 feet through space with that. Or we could move a 772 pound weight 1 foot. And then we've got, let's see, okay, so it's going to take me a while. I've got to write 96 million. So we have 96 million of that unit. This is going to be a lot of foot-pounds, folks. A lot of foot-pounds. Am I there yet? Am I there yet? Is that 96 million yet? Oh, Mr. Harbuck's so funny. He thinks he is. Okay. Anyway, no. We can't write out that many little circles. But the point is, again, if this is 1 BTU, then that means that we have 98,600,000 BTUs, each of which is that many foot-pounds. And so it's clear what we have to do. We have to do 96 million BTU times 772 foot-pounds per BTU. And again, because it's foot-pounds per BTU. That means that BTUs is going to be BTU over BTU. We can just cancel that out. And that's going to leave us with an ungodly number of foot-pounds. Let's do it. Oh, I erased my 98 million. 98.6.
It won't fit our buck.
Oh, yeah, well.
Oh.
Times 772. Okay, yeah, I'm probably going to be wrong here. All right, so how do you do this? How can you do this? Well,
What about
You could write it down.
9.86 times 772, and then add on the amount of decimal points it moved.
Right.
But there's
and
no
this,
zero.
right, and this is one of the reasons we use scientific notation is so that we don't have to type these big, big, huge numbers. So yeah, we can knock all the zeros off, or we'll take this down to scientific notation. So what we do is that in order to figure out how many it is, you put your decimal point here and you count 2, 3, 4, 5, 6, 7. So that's 9.86 times 10 to the 7th BTUs times 772. And then that way we can just multiply this times this, and then we'll put this many zeros at the end. It's not that hard. People get all bollocksed up in the head thinking about this because numbers tend to not sit just right in people's heads, especially at y'all's age, because you're still developing that, and that's okay. I don't think the worse of you for it. I couldn't do math like this until I was literally like almost 30 years old. I was like, click, okay, now I can do this. Takes a little while. See, here's my little... People always ask me, Mr. Auerbach, how am I going to ever apply this? And it's probably true that you will never need to figure out how many foot-pounds a certain number of somebody's going to give you 17 barrels of oil and be like, okay, Alicia, how many foot-pounds is that? And you're going to be like, hey, no problem. But the thing is that it is, people always ask, is this really going to apply to my life? And it is, and this is the way. It's ultimately a lame answer, but it's true anyway, which is that your brain is exercising on these kind of problems. Your brains right now are developing the ability to slot these kinds of problems into place, take these kind of numbers, hold them in your head while you walk around them and look at them from different angles and stuff like that. Not everybody can do that because that's a skill. That's a skill for your brain to be able to take a number, hold it in your head while you think about it a bunch of different ways, and still not forget that number is there and still be able to do the other calculations. That's a muscle that you work out just like anything else. Clearly I'm a master. I'm not actually, but I can play with little numbers like this. Okay, so here's the thing. So where were we? Remember, we turn this into this, and we're going to just multiply 9.86 now. 9.86 times 772. That gives us 7611.92 times 10 to the 7th, right? You can just put that right on the end. Now that's not properly expressed. So first we'll turn it into a big number, then we'll turn it back into scientific notation. How about that? So that's 7611.92 times 10 to the 7th. 1, 2, 3, 4, 5, 6, 7. Good. All right. Okay, so that's 76 billion, 119,200,000. Does that check with everybody here? And if we turn that back into scientific notation, count the zeros. Here's your decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And are we in agreement here that this is
10, yes.
10? So, okay, and then what you want to do is you really want to round it to equal to your largest number of significant digits that you use in the first place, because, in other words, we can't use more decimal points than 3 on this because our answer is really not that exact. So we'll do this down to 3 digits, which would be 7.61, because we don't have to round that. So 7.61 times 10 to the, what was it, 10th?
Uh-huh.
10. What?
Foot-pounds.
Foot-pounds, thank you. Never forget what your units are, because otherwise, it's always a good guide. If you end up with the wrong unit, chances are you did the problem wrong. If you set it up like this, if you end up with the right unit, there's a real good chance that you did the problem the right way. So that's, our answer is a heck of a lot of foot-pounds. We're going to do one more. Don't be afraid. What? Well, I don't know. These guys had an electricity one that they were going to throw at me. Did you guys come up with an electricity one?
Yeah.
He's shaking his head. He's saying yes. So if we maybe we'll do an additional one, Ryan. They were next in line. So okay, last one with the potential for Ryan ruining everything and making you have to do even more work. Rebecca, blame Ryan for this. Not that I won't completely support it.
I don't think we'll have time to.
You don't? Oh! We wasted a perfectly good half day. Why are we watching a movie? Just kidding.
What if your fellow colleagues went on and started watching this?
What's that? Oh, well, you know, there's always that danger, but luckily none of us have enough time to, like, observe each other's work. Nobody has ever, I've got 100 of these. I've got 100 of these up, and no one's ever said anything yet, and I've made very few dirty jokes or anything. So, I mean, there's a couple wrong things that I say sprinkled around there, but I only edit when I'm wrong. If I make a mistake and I look stupid, then I'll go back and edit it. But, you know, I don't remember every semi-inappropriate thing that I say. Okay, so what was your, what do you got?
13 watt hours, whatever it's called, into TNT.
Ooh, okay. 13 watt hours into TNT. Okay, let's get a little perspective on this, folks. 13 watt hours is enough to light one Christmas tree bulb.
Okay.
A 1 watt bulb, a Christmas tree bulb, for 13 hours. So that's like 1/1000th of your Christmas tree for half of a day. Is that a lot of electricity? No, it's not. And we're going to see how many tons of TNT that's equal to. I love it. So, not a lot of, are we going to have a lot of tons of TNT? No. I mean, 1 ton of TNT could light a Christmas tree bulb for probably the rest of eternity as far as the energy, but the other way around, not so much. We're going to have a number with a lot of long decimal point number here. So, I love it. Okay, all right. So, but you know, what I just did there, it's always a good thing to do first. You want to think about what the conversion is, because you want to know if your answer is going to be a lot bigger or a lot smaller than what you started with. So, okay. I think I have 8 minutes here, so hopefully we can do this problem in less than 8 minutes. Early release day, we go to 35. Okay, so here we go. Let's use purple for this. All right, so what do we have here? We can go from, so TNT, tons of TNT. We can either go from calories or BTUs. And it looks to me like I have, the only conversions I have is 1 kilowatt hour equals 3,000, is 1,000 watt hours. And that's 3,413 BTU. Okay, so first of all, I'm going to actually have to convert watt hours to kilowatt hours, I guess. Is that true? Yeah, I am. I think. Or I could just divide this by 1,000, but right, because if 1,000, what this is basically saying is 1,000 watt hours is 3,413 BTU. So I can divide this by 1,000. One watt hour is this divided by 1,000. 3.413 BTUs. Is that unfair for me to do that?
It's fine.
It's fine, because that's what I was going to do anyway. So 1 watt hour is 3.4 BTUs. Okay. I'm so surprised that it's that much. I already feel like I've done something wrong. But I guess I haven't. No, I don't think I have. Okay. All right. So. Okay. So 1 watt hour is 3.413 BTUs. So 3.413 BTUs per watt hour. And so 1 watt hour is that much, and I've got 13 of those. So again, divide or multiply. The answer in this case is multiply. So that's what we'll do. Let's do red. No, let's do blue. Red, no blue. So 13 watt hours times 3.413 BTU per watt hour. Again, watt hour as a unit will cancel out because it's over itself. It's totally over itself. Oh God. So that's 13 times 3.413 equals 44.37. 44.37 BTUs. Okay? So that's not a lot of BTUs. Not bad really, but it's... So, okay, so 44.37 BTUs. And so I've done the first part. Oh, and now I have to do BTUs to TNT. I forgot to write that conversion factor up there. So, tell you what, I'll erase this part. One TNT is 4.14 times 10 to the 6 BTU. Okay, so this is where it gets a little ugly. I'm going to write my. So we have 44.37 BTU. Okay, now. This is where the mathematical reasoning changes a little bit from what we've done. If one TNT is, well, let's just write it out. 4, 1, 4, 1, 2, 3, 4. That's 1, 2, 3, 4, 5, 6. 4,140,000 BTU. And we have 44.37 BTUs. We don't even have 1. We don't even have close to 1. And so this, instead of multiplying, again, if we had a bunch of TNTs, we divide. But this is telling us that we need to actually divide this number in order to get our answer. And so 44.37 BTU, and this is the way I would do this, is it's a division really. So what you're really doing is you multiply it times 1 TNT over 4, 1, 4, 1, 2, 3, 4. 4,140,000 BTU. See, that's really just dividing this by this, but what it allows us to do is it allows us to cancel out BTUs. And what we get, again, is 44.37 times TNT divided by 4,140,000 BTU. And so, 4140, 123, divided. Oh no, I did that wrong. 44.37 divided by 414. 0, 1, 2, 3. Ooh, and that's going to give us 0.00011 TNT. So 13 watt hours equals 0.00011 TNT, or 1100 thousandths, or 1/10,000th of a ton of TNT. Tiny. Have a great weekend, everybody. See you Tuesday. Bye. Could you reach over and hit the red button? Can you reach that for me?